Okay, we want to continue the thought, permutation combination, in how many ways can a four-person committee be selected from a group of 10 people? Okay, we've got a group of 10 people. We're going to select four at a time. Does order matter? We're just going to select four people for a committee. So order does not matter. So this is a combination. So we're going to set up and we're going to go 10, choose 4, okay? And you can enter that then in your calculator. And you're going to get 10, choose, it's a combination, 4 at a time. That's going to be 210. Seems like the magic number lately. Okay, this is 210 ways a four-person committee can be selected from 10 people. Keep that in mind. Keep in mind what you're finding. Okay, in how many ways can you pick a president and a treasurer for your 16-person club? Okay, so does order matter? Yes. We've got a president and we've got a treasurer. So this is a permutation. We've got a 16-person club that you're in. How many ways can you pick those? Well, together, those make 2, so that's your R. So you can either call this 16 permutation of 2, and when you do that, you should get 240. Let's just go ahead and do it. 16 probability of picking 2. Yep. How did I get that? Oh, I used the wrong thing. Let's see. Let's clear that out. Beware, I did it. You could do it too. That is a permutation, and there's 2 people. I just didn't think that number was quite large enough, and there is your 240. Now, since this is a permutation, you can also think about it like I did the other way. You've got 16 people. There's 16 ways to select a president. Once you've selected the president, now you only have 15 people to choose from to make that selection, and that also is 240. And I could simplify this with the formula and show you that this is what you're going to be left with, and you will get the 240. Okay, on an 11-player baseball roster, how many different ways can a 9-person batting order be arranged? Okay, so we're looking at batting order, and we've got 11 people. So if they're talking about order, I would think that order matters. So this would be a permutation. Order matters. We've got a 9-person team. So we can think about 11 permutation of 9. I did that problem. Let's do it on this one just to give you all a variety. I've got 11 people, a variety of calculator use anyway. Let's turn that on. Let's get that overflow off there. Let's clear that. 11 permutation of 9. So I've got 199,584,000. So I have 19,958,400 different ways I can arrange batting order. And this is just ways to do that. You're not specifically putting people in specific order. You can also do that this way. 3, 4, 5, 6, 7, 8, 9. So I've got 9 players. I can pick 11. And then I've picked 11, so now I've got 10, 9, 8, 7, 6, 5, 4, 3. You can multiply that together and you'll get that same notion. All right, let's do this one. Same scenario. Okay. On an 11-player baseball roster, how many different ways can a coach select a group of 9 people to bat? So I think I misspoke on 14. I did tell you that order matters. Yeah, so if you just pick one, then you've got 10 left. So I didn't either. Here, we're just arranging people, okay? I just want to take a group of 11. I want to pull 9 from them, and I want to just arrange them in any random order I can. So order doesn't matter. Okay, so this is a combination. So I'm going to have 11 players. There's my N, there's my R. I'm going to choose to arrange those 9 ways. And that'll be 55 ways to arrange 9 people when order does not matter. Okay, here, order matters. Okay. And that is the end of this section.